Hello, eighth grade. Today we're going to review the definition of direct variation, and then we're going to learn about inverse variation and how they differ. You may remember direct variation we talked about probably last November prior to really as an introduction to linear functions. So if you recall, a direct variation takes the form of y equals kx. And in that form, k is the constant of variation. And it varies directly. X is going to vary directly with y, and that is why it's called a direct variation. This is a proportional relationship. And if you remember, when we graph a direct variation, it is a linear function, so it is a straight line, and 0, 0 is always a point because there's no constant. There's no value being added or subtracted. So y equals kx. K is the direct or the constant of variation. And so that graph would be a straight line through the origin. So an inverse variation is where the form of the equation is x times y is equal to k. X times y is equal to k. Now we still have x and y like we have. K is still the constant of variation. It's just that it's taking a different form. Now k cannot equal 0, but k is a constant. Okay, so what does this look like? Let's create a table of values where x times y is equal to k. So we want to put this in y equals form. So we could divide both sides by x, and y is equal to k divided by x. Okay, that is our equation. So let's make a table of values. And let's say we have x and y, and let's say k is equal to 2. We're just going to say that our equation is going to be y is equal to 2 divided by x. So let's give an x of 2. What happens to y? Well, 2 divided by 2 would be 1. Okay. What if x were negative 2? Then negative 2 divided by negative 2 would give us negative 1. All right. What about an x of 0 we can't have because we can't divide by 0. That won't work. But how about an x of 4 would give us a y of 1/2, and an x of negative 4 would give us a y of negative 1/2. So let's add, so I plotted those 4 points so far. And I'm thinking, you can see it's not linear, right? They're not lined up. We know that x cannot equal 0. So I'm going to put 2 more points here, an x of 1/2 and an x of negative 1/2. And so if we put in 1/2 for x, 2 divided by 1/2 would be 4. And negative 1/2, 2 divided by negative 1/2 would be negative 4. So I'm going to add those points in. So 1/2 positive 4 is going to be like here. And negative 1/2 negative 4 is going to be here. And so you can start seeing that it's going to take sort of an unusual, it's an unusual looking graph compared to what we've done so far. So really what we're going to see is it's going to, do something like this. And we'll get more into that tomorrow, but just wanted to kind of generally get an idea of what a inverse variation graph look like. Now remember, the way we started this is that we said that x times y is equal to k, and then we manipulated that equation so that we got it into a y equals form. But let's go back to our table here. If you multiply our x and y, you get 2, 2, 2, 2, 2, and 2. Every time you multiply the x times the y, you get the k value. All right then, so what really is an inverse variation? Well, in an inverse variation, the values of the two variables change in opposite ways. As one increases, the other is going to decrease. And that'll make more sense as we go forward. So here's an example. My little bike rider, he's traveling at 8 miles per hour and he covered 8 miles in 1 hour. That's what miles per hour means. So if the biker's speed decreases to 4 miles per hour, it would take 2 hours to cover the same distance. So as your speed decreases, the time amount to go the same distance would increase, and vice versa. That was what an inverse variation is. So let's say we wanted to write an equation given a point. So we have a y that varies inversely, important word here, inversely with x. And if x is equal to 7 and y is equal to 5, what would the equation be? Well, we know that xy is equal to k. So if we have an x of 5 and a y of 7, the k has to be 35. So we could write that as y is equal to 35 divided by x. So that is an inverse relationship. You still have that total of 35, and however you get it from x and y, one will increase and one will be decreased depending on the values. So if you had an x of 5 and a y of 7, and you changed your x to 7, then y would drop to 5 because the product of 35 has to maintain. So say we had an x of 3 and a y of -2, and we wanted to write an equation for the inverse variation. We could multiply 3 times -2 and we get the k value of 6, but then we're going to put it in the y equals form. So if we know x times y is equal to 6, then we can manipulate the equation to be y equals 6 divided by x, or -6 in this case. So we're going to assume that y is going to vary inversely with x on these examples, and we want to write an equation. So we can simply write it in the xy equals form. So in this case, number 1, if x is 9 and y is 6, then xy, sorry about that, xy is equal to 54. And we can leave it in that form. We could also put it in y equals form. So all you have to do is multiply the x and y, and that gives you the constant of variation every time. All right, so here we have two sets of points. Each of them lie on a graph of an inverse variation, and your job is to find the missing value. So on number 7, we have a 0.58 and we have 0.4 and m, and we want to figure out what m is. And if they are both on the same part of the same inverse variation, that means their x times y is going to be the same. So in this case, x times y is 40. That means this has to also be 40. So m is equal to 10. Same thing here, 16 times 5 is 80. That means this product also needs to be 80, so h would have to be equal to 8, and so on. So here we have two situations, and we want to determine whether they represent a direct variation, which would be a proportional relationship, or an inverse variation, which would be sort of like the opposite of that. So the cost of a $50 birthday gift is split among some friends. So the way you could think about this is, let's say 2 friends share the cost. Then they would each pay $25, right? But if more friends contributed, that means everybody would pay less. So they are varying inversely with one another. So this would be an inverse variation. Now, you purchase peaches at $1.29 a pound. However, that would be a direct variation because the more peaches you buy, the more it's going to cost you. So we can also look at a table of values and determine whether or not they represent an inverse variation or a direct variation. So on this first problem, we have a product of 70. If you multiply x and y, another product of 70, and another product of 70. So that would be an inverse variation. In this case, if you multiply, we do not get the same product, right? So then you have to look at it a little differently. Well, how does 2 become 4? By doubling. 7 doubled is 14. 10 doubled is not 40. So this is neither one. That is neither one. If this were a 20, then it would definitely be a direct variation. Here's another example of an inverse variation because the product of x and y remains consistent. And this would be another example. X times y was always 24. That means it is an inverse variation. So I'd like you to try some problems on your own. Page 640, 1 through 23. I will have attached the key to Google Classroom so that you can check your work. And I will see you again soon.